Chapter 1. Data Analysis. Introduction. Statistics. The science and art of data. Learning targets. By the end of the section, you should be able to identify the individuals and variables in a set of data. Classify variables as categorical or quantitative. We live in a world of data. Every day, the media report poll results, outcomes of medical studies, and analyses of data on everything from stock prices to standardized test scores to global warming. The data are trying to tell us a story. To understand what the data are saying, you need to learn more about statistics. Definition. Statistics. Statistics is the science and art of collecting, analyzing, and drawing conclusions from data. A solid understanding of statistics will help you make good decisions based on data in your daily life. Organizing data. Every year, the U.S. Census Bureau collects data from over 3 million households as part of the American Community Survey, ACS. The table displays some data from the ACS in a recent year. Most data tables follow this format. Each row describes an individual and each column holds the values of a variable. Definition: individual, variable. An individual is an object described in a set of data. Individuals can be people, animals, or things. A variable is an attribute that can take different values for different individuals. For the American Community Survey dataset, the individuals are households. The variables recorded for each household are region, number of people, time and current dwelling, survey response mode, household income, and whether the dwelling has internet access. Region, time and dwelling, response mode, and internet access status are categorical variables. Number of people and household income are quantitative variables. Note that household is not a variable. The numbers in the household column of the data table are just labels for the individuals in this dataset. Be sure to look for a column of labels, names, numbers, or other identifiers, in any data table you encounter. Definition: categorical variable, quantitative variable. A categorical variable assigns labels that place each individual into a particular group called a category. A quantitative variable takes number values that are quantities, counts, or measurements. Not every variable that takes number values is quantitative. Zip code is one example. Although zip codes are numbers, they are neither counts of anything nor measurements of anything. They are simply labels for a regional location, making zip code a categorical variable. Some variables, such as gender, race, and occupation, are categorical by nature. Time and dwelling from the ACS dataset is also a categorical variable because the values are recorded as intervals of time, such as 2 to 4 years. If time and dwelling had been recorded to the nearest year for each household, this variable would be quantitative. To make life simpler, we sometimes refer to categorical data or quantitative data instead of identifying the variable as categorical or quantitative. Example: census at school. Individuals and variables. Problem: Census at School is an international project that collects data about primary and secondary school students using surveys. Hundreds of thousands of students from Australia, Canada, Ireland, Japan, New Zealand, South Africa, South Korea, the United Kingdom, and the United States have taken part in the project. Data from the surveys are available online. We use the site's Random Data Selector to choose 10 Canadian students who completed the survey in a recent year. The table displays the data. A. Identify the individuals in this dataset. B. What are the variables? Classify each as categorical or quantitative. Solution: A. 10 randomly selected Canadian students who participated in the Census at School survey. B. Categorical. Province, gender, handedness, preferred communication method. Quantitative: number of languages spoken, height in centimeters, wrist circumference in millimeters. We'll see in Chapter 4 why choosing at random, as we did in this example, is a good idea. There is at least one suspicious value in the data table. We doubt that the girl who is 166 centimeters tall really has a wrist circumference of 65 millimeters, about 2.6 inches. Always look to be sure the values make sense. There are two types of quantitative variables: discrete and continuous. Most discrete variables result from counting something, like the number of languages spoken in the preceding example. Continuous variables typically result from measuring something, like height or wrist circumference. Be sure to report the units of measurement, like centimeters for height and millimeters for wrist circumference, for a continuous variable. Definition: discrete variable, continuous variable. A quantitative variable that takes a fixed set of possible values with gaps between them is a discrete variable. A quantitative variable that can take any value in an interval on the number line is a continuous variable. The proper method of data analysis depends on whether a variable is categorical or quantitative. For that reason, it is important to distinguish these two types of variables. The type of data determines what kinds of graphs and which numerical summaries are appropriate. Analyzing data. A variable generally takes values that vary, hence the name variable. Categorical variables sometimes have similar counts in each category, and sometimes don't. For instance, we might have expected similar numbers of males and females in the census at school dataset. But we aren't surprised to see that most students are right-handed. Quantitative variables may take values that are very close together or values that are quite spread out. We call the pattern of variation of a variable its distribution. Definition: distribution. The distribution of a variable tells us what values the variable takes and how often it takes those values. Let's return to the data for the sample of 10 Canadian students from the preceding example. Figure 1.1a shows the distribution of preferred communication method for these students in a bar graph. We can see how many students chose each method from the heights of the bars. Cell phone, 2. Facebook, 1. In-person, 3. Text messaging, 4. Figure 1.1b shows the distribution of number of languages spoken in a dot plot. We can see that 6 students speak 1 language, 3 students speak 2 languages, and 1 student speaks 4 languages. Section 1.1 begins by looking at how to describe the distribution of a single categorical variable and then examines relationships between categorical variables. Sections 1.2 and 1.3 and all of Chapter 2 focus on describing the distribution of a quantitative variable. Chapter 3 investigates relationships between two quantitative variables. In each case, we begin with graphical displays, then add numerical summaries for a more complete description. How to analyze data. Begin by examining each variable by itself. Then move on to study relationships among the variables. Start with a graph or graphs, then add numerical summaries. This process of exploratory data analysis is known as descriptive statistics. Check your understanding. Jake is a car buff who wants to find out more about the vehicles that his classmates drive. He gets permission to go to the student parking lot and record some data. Later, he does some internet research on each model of car he found. Finally, Jake makes a spreadsheet that includes each car's license plate, model, number of cylinders, color, highway gas mileage, weight, and whether it has a navigation system. 1. Identify the individuals in Jake's study. 2. What are the variables? Classify each as categorical or quantitative. 4th, identify each quantitative variable as discrete or continuous. From data analysis to inference. Sometimes we're interested in drawing conclusions that go beyond the data at hand. That's the idea of inferential statistics. In the census at school example, 9 of the 10 randomly selected Canadian students are right-handed. That's 90% of the sample. Can we conclude that exactly 90% of the population of Canadian students who participated in census at school are right-handed? Number. If another random sample of 10 students were selected, the percent who are right-handed might not be exactly 90%. Can we at least say that the actual population value is close to 90%? That depends on what we mean by close. The following activity gives you an idea of how statistical inference works. Activity. Hiring discrimination. It just won't fly. An airline has just finished training 25 pilots, 15 male and 10 female, to become captains. Unfortunately, only 8 captain positions are available right now. Airline managers announced that they will use a lottery to determine which pilots will fill the available positions. The names of all 25 pilots will be written on identical slips of paper. The slips will be placed in a hat, mixed thoroughly, and drawn out one at a time until all 8 captains have been identified. A day later, managers announce the results of the lottery. Of the 8 captains chosen, 5 are female and 3 are male. Some of the male pilots who weren't selected suspect that the lottery was not carried out fairly. One of these pilots asks your statistics class for advice about whether to file a grievance with the pilots' union. The key question in this possible discrimination case seems to be, is it plausible, believable, that these results happened just by chance? To find out, you and your classmates will simulate the lottery process that airline managers said they used. 1. Your teacher will give you a bag with 25 beads, 15 of one color and 10 of another, or 25 slips of paper, 15 labeled M and 10 labeled F, to represent the 25 pilots. Mix the beads, slips thoroughly. Without looking, remove 8 bead slips from the bag. Count the number of female pilots selected. Then return the beads, slips to the bag. 2. Your teacher will draw and label a number line for a class dot plot. On the graph, plot the number of females you got in step 1. 3. Repeat steps 1 and 2 if needed to get a total of at least 40 simulated lottery results for your class. 4. Discuss the results with your classmates. Does it seem plausible that airline managers conducted a fair lottery? What advice would you give the male pilot who contacted you? Introduction. Summary. Statistics is the science and art of collecting, analyzing, and drawing conclusions from data. A data set contains information about a number of individuals. Individuals may be people, animals, or things. For each individual, the data give values for one or more variables. A variable describes some characteristic of an individual, such as a person's height, gender, or salary. A categorical variable assigns a label that places each individual in one of several groups, such as male or female. A quantitative variable has numerical values that count or measure some characteristic of each individual, such as number of siblings or height in meters. There are 2 types of quantitative variables: discrete and continuous. A discrete variable has a fixed set of possible numeric values with gaps between them. A continuous variable can take any value in an interval on the number line. Discrete variables usually result from counting something. Continuous variables usually result from measuring something. The distribution of a variable describes what values the variable takes and how often it takes them.